You put in here, cam lock's easy just to take it off, blow it out, clean it out, run water into it. Ramon's going to be putting an additional circulating blowout system or clean out system into it, so you can truly flush the entire system without having to pull anything off and use nurse hoses to get into it. It's all being fed by 3/4 inch lines and then drops down into a 1/2 inch. And so that 1/2 inch line is what's providing the pressure. And we'll talk a lot about the pressure, the speeds, the outputs, basically call it feeds and speeds, how much you're giving the machine, how fast you're going to get the amount of pressure and spray that you want into it. We've gone to a 1/2 inch line underneath there, which is very indicative or representative of the bar sprayer. They'll drop those 1/2 inch lines into their spray bar. You eliminate a lot of pressure drop. You go smaller, you start to restrict, and you will notice pressure drop out into the sprayer. Once we notice that, we changed everything over to 1/2 inch. Probably change it to a 3/4 inch and make it just a 1-for-1 straight all the way through it. But that might be a little overkill. You start running out of room underneath the pods, and that makes it a little bit problematic. Each one of these pods, and you can probably all see it from where you are, is connected directly to the side wall with swivels. All right. With these swivels, this allows you to get into the crop and position yourself right where you want it to be coming in from the side. You also have air coming in from the side. Can we lift this all the way up, Ramon? All right. If you take a look at what we've got here, stainless steel bar with your spray nozzles connected to it. If I was to extend that in a straight line all the way out, take the hoods or the pods off of it, what would you have? Just a standard bar sprayer. It's no different. Spray down technology at that point, if you don't have the hoods on it, and or these would represent what? Drops, right? So coming in on the side of the furrows and the top of the bed, you cover it from the sides. So there's absolutely really no difference between this setup and a bar sprayer. With these being on swivels, it gives you an advantage. Some of the drops that you'll see will have the swivel on the sides. We put 2 of them in there and not 1. Most drops just have 1 swivel, so you are where you are. Bar sprayers sway a lot. If you've been out there and literally watched a bar sprayer, and you see that thing doing this, well, these are heavy enough to where it's not going to get you a lot of movement. It'll get you some movement, but it's not going to get you this type of deflection. If you get that type of deflection on a bar sprayer, every time that goes up, what's happening? You're creating a gap that's wider than necessary for your spray material that's going to be either carried out into drift or it's going to skip. So you're going to have areas in the field, every time that boom lifts up, there's a pattern that's missing, and you're not spraying effectively in that area. So this design is going to keep you down on the ground a little bit more. It's not going to sway as much, and you're going to be more effective with being able to position these and knowing where your spray content is going. Air nozzles, spray tips, and spray nozzles. All right, so each one of these are removable. There's also caps and plugs, so we can plug each one of these holes if we wanted to. Based on different products or different growth cycles, you may want to put a cap in there. All right, we've got some of these that have got partitions that split a pod. You've got an 80-inch machine, but you've got a customer that's got 40s. Well, okay, so I've got this great big hood that's covering both 40s, but it's also got air that's pushing right down into the furrow. That's going to kick up a lot of dust. That dirt's going to go blowing right into the crop. It's not going to give you as effective spray. So we built partitions that literally lock in on that 3-row machine. You've got an extra one of these bars. It slips right into place here and here. We cut the hole out a little bit bigger there and then have a cap for it when it needs to be removed. That plugs right into the air. Now you've got a partition that splits that, so you can have 40s on an 80-inch machine in about 10 minutes of change-out time. You just literally drop this out, slip the other one in, bolt it back on from the top. Once that's done, that center pod's got, or partition's got air that comes out of the sides. Now you get into a broccoli that's on 40s, now you can be effective. If you try to run an 80-inch machine on broccoli that's 40s, you got to do something with that air in the center to not kick up dust, and you're still now asking air to come in from this side and this side, but this side of the crop going out, you're not getting it. So you have to put partitions in it. Partitions are very easy and simple, and it's more of an add-on. It doesn't come standard with the sprayer. A lot of guys are just staying in big beds, and that's where they're going to use it. So if they are going to switch out, absolutely, it's an option. Backside here you see vacuum. What that vacuum does is as you're putting your material down, hitting the contact, you're going to have some drift or some residual spray. The vacuum is designed to control some of that drift, and it's actually going to pull the drift back up into the system, making this a recirculating system, not a recycling system, it recirculates. So it pulls it back down the air in, or vacuum tube, it goes back in the fan housing. That pushes it back out into the air stream, which begs a question. I'm in lettuce and I'm really worried about spore migration. I can't, take this and just putting spores back in the machine and pushing it back out. That being said, you're pulling it back in, you're also pulling drift back in, you're pulling content, spray content back in with it. Once it goes through the system and comes back to the air holes, it's being sprayed again. All right, so the studies at the University of Davis that were done, we identified that as a potential problem. They studied enough and said, absolutely not, you're killing it twice, basically. When you pull a spore up with the material that would be considered drift, and you're pushing it back out and respraying, you're basically killing it twice. You're never gonna have a problem with spore migration, right? But because we are pulling materials back up, that is running back into the fan housing, we definitely wanna make sure that fans are cleaned, all right? So rinsing them out, spraying them out, and it's as simple as literally running water down into the tubes. You can run enough water down into that where it will fill that fan cavity up. Right? When that fan cavity's filled up, we flip the blower on, and that's going to do what? It's going to agitate the daylights out of it, and it'll absolutely clean it. You guys have probably had experience with cleaning these things out successfully. You used them enough times to where you get them clean. Yeah. Fair to say. Mm-hmm. Okay. Good enough. So they, it does take a little bit longer than a bar sprayer to clean. It's a bar sprayer. All you're going to do is flush it. And it's just spraying straight down. There's nothing else.
We're going to call you on this. I brought my agronomist just to keep you honest.
Okay. Perfect. You can call me whenever you want. But make sure you clean it. So I would tell your agronomist to make sure your guys clean, or your customers clean their machines out. If you don't, and you're going to use a surround, or you're going to use something that's got some kind of chalky buildup to it, just make sure it's clean. Make sure it's rinsed and flushed out. Triple rinse it. I mean, what's that, what's the cleaning agent, Nutrasol? Is a very,
K80.
What's?
K80 sorry.
Chlorine? Whatever you're going to use, that's a very effective agent. But if you don't clean your machines, all bets are off. I mean, you will get buildup over time. So that's generally the components, or not much else. As I mentioned, we were talking about the PTO pump. This is the PTO pump that's on the back side of the machine right here. I'm sure everybody's familiar with the PTO pump. That's the Kim pump. All right, so the Kim pump is in front of the PTO pump. That's the component, because the tractor's the tractor, the sprayer's the sprayer, and that's like the missing link. It's the piece that we always forget to talk about or discuss, and then there's always a question about a Kim pump at the end of the day. The D250 is what we use as a standard. That doesn't mean that you have to use a D250. Some outputs are not going to be crazy. I mean, some of these guys in vegetables are just going to run a 45, 50, maybe 60 or 70 gallons output per acre. Does that require a D250? No. D250 allows you to get up to 250, 300. It's actually 300 gallons per acre output on the D250, and it will accommodate the pressure. Smaller pumps may not accommodate the pressure. I use that as a standard just because I understand that pump, and I know I'm going to get the performance out no matter what I do. year down the road, 2 years down the road, I want to go change my program up, or I want to use it, in a different area that needs or requires more pressure, it's already accommodated. I don't have to worry about going back in. We had used a D160 at one point in time. Great pump, worked perfect for what we were doing, but then we tried to go into strawberries with it, and it just didn't give us the output that we were required. Strawberries are going to require a lot more pressure and gallons per acre than vegetables. I would say that typical strawberries, 150 gallons, yeah, at about 100 psi, 125 psi. That's a typical strawberry application output. Vegetables, 50, muskmelon, 75.
Unless it's organic.
Well, yeah, we've got a couple of organic growers out there that I don't know what they're thinking, but they just blast the daylights out of their crop. And
150, right?
it's yeah, it was 150 gallons per acre output with organic materials. Organic materials are extremely expensive, but I guess at 150 gallons per acre, it worked. When they were walking the fields after that spray, the beetles were they were looking at them and they could see them in the field right next to the crop, where I don't know if it was the pressure, I don't know if it was just flooding them or what happened, but they were literally in the field, dropped off the crop. So it seemed to work. They got
Whatever makes
50%.
Whole Foods happy.
What's that?
Whatever makes Whole Foods happy.
Exactly. They were getting a 50% increase in efficacy. So that's really what we're driving at. So is there any question?